Today, my friends, I keep on working with the Overkill KAWASAKI engine, and cylinder is somewhat done. I call it done, as I do not find anything new to grind off. But there isn't. I ain't calling it 100% done. It might be something left to do. But let's take that on further away from this point. I thought I'd talk to you a little bit about how I designed the rotary inlet. I haven't designed it completely yet. I'm in a mock-up state, and I'll bring you along right now as I'm about to do some test fitting and present my ideas how to drive it and stuff. So yeah, let's go. Yes, here we got the engine. I received a new piston, of course. I have set the heights. I also made some bolts so I can bolt it together, and now I'm able to turn it around. I will take the whole engine apart later on and clean it. This is the balance shaft though, and yeah, as you know, this is the room for the slipper clutch. But I got another slipper clutch system. I will probably use this one instead. This is a semi-slipper clutch. This, what I've got inside right now, is activated by engine RPM, and that makes the engine a really boring engine. There aren't possibilities to have any fun at all on the street, because no matter what gear, it doesn't pull anything underneath the clutch is locking up. So let's say you're driving on the 5th gear in 10 kilometers an hour, you lose speed. As you pull on the throttle and the engine goes up to 8,000 RPM or something like that, 6,000, and it, as it is high gear and low miles per hour, and yeah, it isn't fun at all. Only race. But this one instead, I have the arms. The mechanism is the gearbox is full of oil, so I won't take it apart right now. But the levers and weights are on that one instead. This one is mounted to the input gear, the gear input shaft, and thereby it locks up. The more speed you get, the more this one locks up. The other one is the more speed the crankshaft is getting, it locks up. Do you understand the difference? The more vehicle speed with this one, that means you can use springs and have very soft springs and just be able to cruise around at any gear, at any speed, and just like an ordinary street bike. But when on low mile per hour, let's say 10 to 50 miles an hour underneath, if having really soft springs, if you're hitting the throttle, it will slip the clutch, and when the speed is increasing, the centrifugal force is giving pressure on the clutch, and thereby it locks up by speed. I might use this one instead. It's becoming far more usable on the street, and you can use it on the drag race also, because you can have these soft springs standing still, and let's say you're running 8,000 RPM or whatever, 6,000 RPM on a two-step, and then just release the two-step on the clutch. It's activated by the clutch. It pulls away softly with a calculated slip on the clutch, and when speed is increasing, it starts to lock up. This way you can control the start quite nice. This system though is on first gear. No, not this system. The system that's inside now. When on first gear, and let's say you're having, you don't have the clutch. You don't need the clutch lever at all. You can just. I have deleted it on this setup, and you can rev. Let's say your a push button with a two-step. Let's say you set it at 6,000 RPM and full throttle, and just release the button, and then it puts, because the engine revs up and the clutch starts to grab and it pulls. Only race. So I got these two setups to choose from. This one's more usable on the street, so I might go that route, because I actually want to run it on the street a little bit as I'm building the chassis for two engines, and in a cafe racer look. I want to be able to use it on the street. I find that quite interesting actually. Could be fun. That's the word I'm seeking. So my plan is to, when I made this, I got such a long connecting rod so I can put the cylinder upward a hefty bit. And my plan is to, like, I have some old, it has come off, weld up some more on the engine and wheel it down. And then make an inlet like this, and don't know if you can see, it's very bad, but somewhere in this region make an inlet like that and upwards, so I can get underneath the sleeve, the cylinder skirt, and I have bolted it down now so I can set the heights. I have started sketching on a new cylinder head, because for some reason on eBay the value on used TM racing heads is just through the roof. I don't know why. The cylinders are expensive also, yes, but that's a cylinder. A head is just a head. So I got this, but this is for the old Kawasaki. I got the combustion chamber at the guy who's helping, that I'm not helping, a guy who's I'm borrowing his lathe from. So I will use the head and make a new. This one's too small, and it's for 7 bolts. This is a 6 bolts. So I will make a new one. But now to the interesting part maybe. This is quite heavy right now because it's mocking up stage still. This is a Rotax disc, and I haven't milled out all the intake area because probably we'll need to aim it upwards or something, so I left material to be able to hand port it. And where's the disc? And I made this contraption with 90-degree angle. I haven't made the lid yet, so I'm about to make that one. And you see, now you can, this is a 1-to-1 drive of course. And I'll place this one like this, as close to the cylinder of course as possible. And you can see this is the intake, it will go inside here. I'll need to, oops, I dropped the bearing. I can take this off. That is, I milled some grooves for the lubrication of the disc also. I'm using steel disc to have no issues. It creates some imbalance, but the weight of this, that's nothing to care about. And then I will turn it a little bit like this. I have marked, I will cut the I'll do it just after I talk to you guys. I'll cut this bung off a little bit so I can get this further close. And then I will actually, from the crankshaft, make a pulley, and then a pulley, and a belt drive. And I do not like the setups people are doing with the bent, with the two rollers over here that bends the belt. I don't know, but I think those setups are eating the belt. And I like a straight belt and mechanical 90-degree angle drive. I think it is quite sloppy now because the lid will contain a holder for this bearing also. And then it becomes very solid and exact. As you can see, I'll place this right here, as I said. And then the pulleys, I will make one of them solid and be able to use a crank sensor at the same time in that one to use the Max SU or something similar, or Ignitec if I'm buying that again. Probably not. I'll see whatever route I'm taking. I will make a pulley for that, and the other pulley I will make it as adjustable cam gears on 4-stroke engines, so I can adjust the angles on the disc and not open this. I will make the adjustment slots long enough to be from one tooth to another tooth. In that case, if wanting more adjustment, I can take it apart and move it one tooth and then start over. That's the thought of this one. It's heavy now, yes, it's really heavy. It's that bearing. That's a little bastard. Yeah, whatever. I have to blame my suit myself. What I'm asking for trouble when putting it here all the time also. But I will mill off some leftover material when I'm done, because this is heavy. It's like, I don't know, 2 kilos maybe. And there's the lid up on this one also then, but that will be thinner. That will just be like 3 centimeters, 30 millimeters, and slots milled into to get it lighter. So I just cut that bung off, not bung, that bracket off right now when we're talking, and I'm quite happy with the result of this. I'll put it away. I don't want to introduce shavings into it if I can avoid it. And now I'm quite lazy. Should I be or should I not? No, I'm not that lazy today. I take the cylinder off and cut it. Oh, that's 30. Yeah. I will buy some new nuts. These are some homemade K-nuts. A K-nut is a nut with a washer and built into it, and a small number to get a small. This is millimeter 10 and 30 millimeters, and one of them is 12 actually. I just took what I had, but I'll buy new. I have a website. I got a shopping basket. I just have to send it. I just have to send it. I have also ordered a front fork for the chassis. I ordered the same fork from the same bike, that KTM Duke 390, I'm thinking it is. Like this. And now I have only made 4 M8 nuts to bolt down this adapter. I will put a lot more bolts around everywhere because this is for millimeter 10 and this is for millimeter 8. If getting much cylinder pressure, it will just pull the cylinder off the crankcase. So we'll set in some more, maybe spread around a whole lot of millimeter 6 studs all around. But I'll take that later on. I'm quite happy with the cylinder actually. I have bead blasted it also and finalized it. I milled the skirt and I milled the height. I will still put the helicoil thread, but I will put in all of them. There are one insert in this one, I will leave that one. But I will put helicoil in the other ones. So I'll take this away, put it on the chair. Now I can be able to cut. This is not how to do it if you want to do it nicely, but I'm a nice guy, so I don't have to do this nicely. I need to be a rebel sometimes. I got the lubrication. That wax is working equally as good with cutting in with the death wheel. So that one and that one, I need my glasses. I'm still waiting for the fork though, so I'm doing things like this in the meantime. I will mark up this a little bit so I can aim a little bit more. And the advantage of never cleaning the desk too much, the workbench, is that you always got some tools you can need with arm length distance. You have to look for advantages in the chaos. Use this as a to bolt the disc onto also. If it cut too much, I'll just shim it with something. So now bring up the engine again. I will take away some dirt from this. Now it got full of dirt. Yeah. It's clean though, so it shouldn't stick anything to it. Always. That's an old habit. Even the go-kart engine I'm always putting on the wrong side. Right there. This one's got 12 millimeters. Put that right here because it's tight fit in this corner. Begin to see the advantages of just putting the tools everywhere. Yeah, I just pull them, I just take them. And there should be gaskets, 0.4 millimeter and 0.4 millimeter. I calculated that. So now I can take that disc inlet again. Need some lighting though, so you can see. So maybe where did I put it? Right here. Now I can get closer. Sorry, I need to look. You can see my idea now. And the crank is pulling this one. Oops. Yeah, you can see catch my idea. So that's how I'm thinking of this one. I will take the engine apart some. It's full of oil now though. So maybe I should do it right now anyway. I can put it like this. I can put it like this and the oil won't pour out from it. Like that. And then now it's almost solid. It's good enough. Almost solid is good enough. I thought I'd show you the clutch. I need to find my Allen wrench. Allen's got a hold of it again. That one I didn't have in my arm length. There it is. Are you able to see what I'm doing though? Yes. I got this shaving in my finger. Whatever. I got new ones. And you might think I got, let's say this one is 30mm thick. I do not have a 30mm thick, 30mm longer rod. It's because the TM racing is inside another height settings than the Kawasaki cylinder. The Kawasaki cylinder needs just about 17mm. I wonder if the rod is 17mm. It depends on the piston also though. I use KTM pistons, 80, 82 Bussners. Those ones got the this is an 80, 82. 80, 82 DA. This one's junk. It's cracked and it has seized and it's been through hell and back. Whatever. It got the ring locator pin at 6 o'clock and putting that straight into the boost, the C port. You can port the cylinder. The B port you can port it quite a lot, and the B port is what you can get the most power from if you're concentrating on designing them correct. The A port, in that case you're designing them to keep the flow inside, keep the air column inside the cylinder without escaping into the exhaust. And the C port helps pushing it upwards. And timing this correctly, you get this air column and almost stays on top when the piston is traveling upwards and trapping the air inside. You got the pulse from the exhaust also pushing up some new fresh gases that are sucked out. So now let's check. This is the look of it. It's quite heavy setup though, but it also has a little bit with, I wanted some inertia to help this, as this is when the engine is revving, this follows. So there's a steel ring on the outside right here that gives it inertia, so it helps overcome bogging at the start line a little bit, not much, but the initial clutch hit is a little bit more weight into it, so it will have some oomph from the line. But as you can see right here, this time I got some springs, but they are very soft. I can't remember why. Is it because I wanted it to test it? This is several years ago, I can't remember. Is it because I wanted it to be able to test it on the street, because the RPM issue I talked about earlier with no pull underneath any. Well, whatever. You can see I got a lot of bolts and washers and everything on these ones because they are weight. No, it's rust. It has sat for many years though. You can adjust the centrifugal force with choosing the amount of weight you're putting on the levers to get some force that's clamping. And this one, when it revs, this one wants to go like this. So these are made like a C. So they're pushing on the clutch on the other side. You can't see it from me, well, not me either right now. But on the clutch disc, pushes on that one when the RPM is getting higher. And the other one, where did I put it? I had it just underneath my intake. I take away all this system, and this one is bolted onto where the springs are located, OEM, but I take these levers and put them on this one instead. This one is not used anymore, and this one instead. So this one's getting its drive force from the clutch basket. This one isn't. This one is giving its drive force onto the input shaft. Well, that's about it. I'll end off here, and yeah, I'll end off here and see you next time. Bye.